my name is Jodi James. I'm a student at Fort Lewis College, and this is my presentation on RR Lyrae Variable stars. My purpose of this research was to observe pulsation in these stars and also attempt to find the Blaschko effect. So RR Lyrae stars are old stars in globular clusters that are located on the instability strip on the Hertzsprung-Russell diagram, which means that they ran out of hydrogen in their core. And they're all in a tiny little cluster, so they have a constant magnitude of 0.75 mag. And then because of that, they are classified as standard candles, which help determine the distances of a star from Earth. And then this is the equation that helps find that, as long as you know the absolute magnitude and the apparent magnitude. And then Hipparchus, a Greek astronomer from long ago, defined the brightest magnitude of the first and then the sixth magnitude of the dimmest. So here we have a little example of the Blaschko effect, and the Blaschko effect is the change in amplitude and the frequency. So here is an example of changing in amplitude and some in the period. So I took my observations from the old fort near Hesperus, Colorado, using a 16-inch Me telescope, and I had to take darks and some flats. So those correct for thermal noise and the corrections in the camera, the vignetting, so the roundness, and also the little dust particles. And we used that to get a reduced image of all my observations. So I was able to pick 7 RR Lyrae stars, and these are, everything in red is the RR Lyrae stars that I've chosen. And then this graph, or this table, describes the catalog of these stars using the StarX catalog. It determines the magnitude and distance, or location. And here is a pixel counting on how to convert my images into numerical data. And that brings out to my light curves. So my light curves, this is from October to December. And then this is is a resulting average of my relative magnitudes, and these are my relative magnitudes, the red being the target stars and the gray being the comparison stars. So I use all of that to get into a phase reconstruction, so overlapping all of these data that I have on there, and that would find the F-min search for the period. And then over there are my final light curves. So light curves A and B have the possible Blaschko effect happening in, because one has the changing amplitude and also the period, and the other has a changing period. So graph F and G are different. So graph F has a longer period range of 1.4, which indicates it's a possible Cepheid variable star, and then the other one, since it has a quick little dip and goes back up, it is considered a possible eclipsing binary. And then out of my accomplishments, I was able to observe these RR Lyrae stars for 15 nights, able to possibly show the Blaschko effect, a Cepheid star, and an eclipsing binary. For future work, I would like to pick out more stars from my observations, and also work with other observatories in the Colorado Space Grant Consortium group. And I would like to thank Dr. Hakes, Dr. Randy Palmer, Ellie Mullen, FLC Writing Center, and the FLC Physics and Engineering Department.